Do you know how many blood group systems exist and their clinical relevance? Blood group systems, they're more than just the A, B, and O types we often hear about. In fact, there are 43 recognized blood group systems, each one unique, based on various elements like glycoproteins, lipoproteins, carbohydrates, and other proteins present. But here's the catch. Not all these systems carry equal weight in the medical world. Only a select few are clinically significant, meaning they have direct impact on our health and medical treatments. These systems are extensively studied and recognized for their relevance in areas like blood transfusion and organ transplantation. They also play a crucial role in understanding disease susceptibility and even our genetic history. So, while all 43 systems are fascinating in their own right, today we'll be focusing on those that matter most in the clinical context. Now, let's delve into some of the most common ones. First up, we have the Lewis blood group system. This fascinating system is based on the Lewis or Le glycoprotein antigens. These antigens are coded by two genes, the FUT3 gene, also known as the Lewis gene, and the FUT2 gene, more commonly referred to as the secretor gene. Both of these genes can be found on chromosome 3. There are two primary antigens in the Lewis blood group system, the Le and Leb antigens. These antigens give rise to three main phenotypes. The first is Le A plus B, the second is Le AB plus, and the final one is Le AB. Understanding these phenotypes and the Lewis blood group system as a whole is crucial for many reasons. It plays a significant role in many areas of medicine, including transfusion and transplantation medicine, pharmacogenetics, and even in understanding certain disease mechanisms. This system is named after Lewis, the person who discovered it. Next, we have the Duffy blood group system. This intriguing system is based on the 5 glycoprotein blood antigens that reside in the cell membrane of our red blood cells. The 5 antigens are specifically encoded by the dark gene. Now, within this system, there are 5 phenotypes that we can identify. These are Fire plus B plus, Fire plus B, Fire B plus, and Fia B. But what does this mean in the grand scheme of things? Well, these antigens and their corresponding antibodies are rarely associated with transfusion reactions or erythroblastosis fetalis, a condition that can occur when a fetus and mother have incompatible blood types. The Duffy blood group system, while not as commonly discussed as ABO or Rh, is still a fascinating topic within the realm of blood group systems. This system was first described back in 1950. Moving on, we have the KID and YIT blood group systems. Let's dive in. The KID blood group system, named after the patient in whom it was first discovered, revolves around 3 major antigens. These are JKA, JKB, and JK3, which are encoded by the SLC14A1 gene found on chromosome 18. Now, these antigens might sound like a bunch of letters and numbers, but they play a significant role in our health. Specifically, the antibodies produced in response to these antigens can cause a severe hemolytic transfusion reaction. This is a dangerous complication of blood transfusion where the recipient's body attacks the transfused red blood cells, leading to their destruction. Switching gears, let's talk about the YT blood group system, also known as the Cartwright blood group system. It is based on the YT antigens present on the surface of our red blood cells. There are 2 major players here, the YT and YTB antigens, encoded by the H gene. Just like in the KID system, antibodies produced against these antigens are of clinical importance. They are associated with delayed type transfusion reactions, a less immediate but nonetheless significant response to incompatible blood transfusion. To think, these intricate systems were first identified way back in 1951, and their discoveries have since paved the way for safer and more effective blood transfusions. It's incredible, isn't it? The more we learn about our bodies, the better we become at caring for them. So, in a nutshell, the KID and YT blood group systems are unique in their makeup and clinical implications. They remind us of the complexity of our bodies and the importance of understanding them to the best of our abilities. And with that, we have covered the KID and white blood group systems. These systems were identified in 1951 and are known for their association with transfusion reactions. Lastly, we have the XEG and Dombrok blood group systems. The XG blood group system, first described in 1962, is unique. It's based on the XG protein antigens found in the cell membrane of red blood cells with corresponding antibodies in the plasma. There are two major antigens in this system, XGA and CD99. These antigens are encoded by the PBDX gene located on the X chromosome. But here's the interesting part. The XG system is not associated with any transfusion reaction. That's right. No known transfusion reactions have been reported for this blood type. Meanwhile, the Dombrok blood group system, first identified in 1965, is based on the DO antigens in the cell membrane of red blood cells. This system is a bit more complex, with 5 major antigens, namely DOA, DOB, GAIA, HI, and JOA, which are encoded by the ART4 gene. Unlike the XG system, the Dombrok blood group system has been linked to severe transfusion reactions. In fact, reports of serious reactions associated with Dombrok antigen-antibody interaction have been documented. So, you see, every blood group system has its unique characteristics and clinical relevance. From the antigens present to the potential for transfusion reactions, these systems underscore the complexity and diversity of human blood. The XG system is not associated with any transfusion reaction, while the Dombrok system has been linked to severe reactions. To wrap up, we've covered 6 of the most common blood group systems, from the Lewis system with its Li antigens to the Duffy system's Phi antigens. We've delved into the KID system's JK antigens and the YT system's YT antigens. We've also explored the XG system's unique protein antigens and the Dombrok system's DO antigens. Understanding these systems is crucial for medical professionals, especially when it comes to blood transfusions and disease susceptibility. Thanks for tuning in.